Hi and welcome to this Junior Cycle Higher Level Maths Revision video. Today we're going to be revising how to solve quadratic equations. We're going to cover two specific methods. The first is the factorization method and the second is the quadratic formula. Finally, we're going to look at some equations that contain fractions. So let's revise the idea of a quadratic. The name quadratic comes from quad, which means square, because the variable gets squared. So for example, we're generally working with an x squared. We can also say that this is degree 2 because of the power 2 on the x. The graph of quadratic, I think, is really important. You may or may not have seen this as you're solving quadratics, but I think it's important to understand what we're doing in terms of our graphs. So there are two graphs that we have. We have a positive graph and a negative graph. A great way to remember this is positive people smile, negative people frown. If we take a closer look at the graph, I have two red dots on each, and these are called the roots. When we're solving a quadratic equation, what we are doing is we are finding these roots. The roots are where the graph cuts the x-axis. Because of the shape of the quadratic, we usually get two answers. And I know that there will be some students out there going, but yes, usually get two answers. Because it's a quadratic, an x squared, power 2, that 2 implies that there is two roots. Now, we don't have to worry about that. We'll see what happens if there's only one root. Beyond that, we're talking leaving cert material. So there's my positive, there's my negative, and here are the roots. So before we get into the idea of solving, it's important that you understand how to factorize quadratics. If you haven't already revised this, I suggest that you revise it using the video I've linked in the description below. So let's talk about the zero product property. If we have two numbers that are multiplied together and their product is 0, what do we know about the values of A and B? Well, either A equals 0 or B equals 0. So this idea is called the zero product property. There is only one way we can get a 0, and that is at least one of the numbers we're multiplying is 0. So maybe A is 0, maybe B is 0, or maybe both are 0. We're going to use this zero product property to help us to figure out the answers to our quadratics, i.e. solve our quadratics or find the roots. Let's start with an example. Solve 3x squared plus x minus 14 equals 0. So we're going to use factorization. I'm going to use guide number method. So my guide number is the first number multiplied by the last number. And this gives us minus 42. Nope. So negative, watch your signs, minus 42. So minus is a little bit more tricky to work with. It means that the factors we're looking for have different signs. So we're trying to find factors of 42 that when we subtract them, give us the number in the middle. So the coefficient of the x term. Now there is no coefficient, but that means that there is a coefficient of 1. Remember, if I have an x, I have 1x. So the numbers I think we want are 6 and 7. I want a positive 1 as an answer. So that's going to be plus 7 minus 6. So then we're going to break up that 1x into minus 6x plus 7x minus 14. This time we have an equal 0 here at the end. The reason I've done that is so I can do some grouping. I'm going to group these as is. There is a 3x common, leaving me with x minus 2. Plus, remember, your sign will always come from the third term. 7 is common, x minus 2. That equals 0 just sits there. It's not getting involved. We don't have to worry about it yet. We double check our brackets are the same. They are. We'll pull these out. Remember, the order of your brackets is not important. So if you get a different order, it's absolutely fine. Everything we've done to this point is the factorization type 3 guide number. You may use other methods to factorize, trial and error. That's absolutely fine, but we should end up with the same answer. Remember, multiplication is commutative, so the order of the brackets is not important. So if you have 3x plus 7 times x minus 2, that's exactly the same. Now we're going to apply the zero product property. So I have two brackets, and when they're multiplied, they equal 0. So either x minus 2 equals 0, or 3x plus 7 equals 0. So that is our zero product property. And what we've done here is created two little linear equations. I'm going to use vertical balancing. So I'm going to add a 2 to both sides. And that gives me x equals 2 as an answer. Here, I'm going to take away a 7 from both sides. Minus 7. And I'm left with 3x equals minus 7. To finish that, I divide both sides by 3. I'm going to leave that as my answer. I'm not going to write it as decimal because it's going to be recurring. I'm not going to write it as a mixed number. I'm going to leave it as a top-heavy fraction. So all we've done is factorized and then applied the zero product property. Let's look at a few more examples. So the first one here, use factors to solve 12 minus 6x minus 6x squared equals 0. So the first thing I notice about this is that it's written the wrong way around. So I'm going to write it like a normal, quadratic trinomial. I'm going to write the x squared term, then the x term, then the constant. Now, this is a negative quadratic, and how I know that it's a negative quadratic is because the leading coefficient is x squared. The leading coefficient is the number in front of the x squared. So because that term with all the power is negative, then the whole thing is negative. Now, I don't like working with negatives, and I will avoid it if at all possible. Lucky for us, we're dealing with an equation. Remember, an equation is all about balance. So I can do whatever I want as long as I do it to both sides of the equation. So not only are the signs a problem for me, I've noticed that there is a 6 that could be divided into all terms. So I'm going to divide by a minus 6. So when I have minus 6 divided by minus 6, I'm left with 1, or simply x squared, plus, so minus 6 divided by minus 6, again 1, or just x, and then I've minus 2 equals 0. So what I've actually done is I've completely simplified my equation. Do you have to do that? No. I wouldn't recommend doing guide number with a negative quadratic, but you could have just changed the sign. So you could have worked with 6x squared plus 6x minus 12 equals 0. But what I've done now is I've created a quadratic that has just got an x squared at the start, which means I can use the shortcut. So you're saving yourself a little bit of work. So guide number is minus 2. I want to add to 1x there in the middle. So it's going to be 2 by 1. I'm going to have a plus 2 and a minus 1. The shortcut is simply opening your two brackets and putting plus 2 in one bracket and minus 1 in the other. Because this is solving and I have a little bit extra work to do, if I can save a few lines, I will. But if you want to do full guide number, that's perfect. Now that I've got my factors equal to 0, I'm going to use my zero product property. So either x plus 2 equals 0 or x minus 1 equals 0. I'm going to use vertical balancing and take away a 2 from both sides. When I do that, I get x equals minus 2. The second one, x minus 1 equals 0. I'm going to add a 1 to both sides, and I get x equals 1, and they are my two answers. Again, if you're unfamiliar with this or if you're struggling with any of the concepts, do revise Linear equations, which will go through the idea of being able to change an equation as long as we keep the balance, and also the factorization video, which will go through in more detail guide number and the shortcut. So part 2 of this example, y squared minus 5y equals 0. This is a quadratic because it is y squared, okay? Variable is y in this case. Doesn't matter, it's not going to change anything. However, it's not a quadratic trinomial. It's only got a y squared and a y. Now, you could argue that it has a 0 constant, but it doesn't look like a quadratic that we had in part I, the first part. Instead, we're going to use a different type of factorization. We're going to use highest common factor. So y is common, leaving us with y minus 5, and that all equals 0. How easy was that? Now, using our zero product property, either y is 0 or y minus 5 is 0. Y equals 0 is my answer. So the second one, vertical balancing, I'm going to add a 5 to both sides and we get y equals 5. So my two answers are y equals 0 and y equals 5. So just be aware, just because it's quadratic doesn't mean we're going to be using guide number. We may also be using highest common factor, or like in part 3 here, a different type of factorization. So if we look at part 3, it's not highest common factor. Well, there's a 4 common, but that's not going to be hugely helpful. We might just leave it there for a minute. It is actually a difference of 2 squares. So I have 2t squared minus 10 squared. That gives me 2t and 10. 2t and 10. Remember, a plus goes in one bracket, a minus in the other. 2t plus 10 equals 0, so that's one possibility, or 2t minus 10 equals 0. Some vertical balancing, I'm going to take away a 10 from both sides here. I get 2t equals minus 10. Divide both sides by 2, and my answer is t equals minus 5. The second answer is add a 10 to both sides. And when we add that 10 to both sides, we get 2t equals 10. Divide both sides by 2, and we get t equals 5. So there are our two answers. So now let's talk about quadratic formula. So the quadratic formula is also known as the minus b formula, and it can be used to solve any quadratic equation. Now, if you despise, or maybe that's too strong a word, if you are not a fan of factorization and you think that this is going to solve all your problems, it will only solve half of them because it can only be used to solve equations. So you could still be asked to factorize your quadratic. So it's still important you understand how to factorize. This is what the formula looks like. It is x equals minus b plus or minus square root of b squared minus 4ac all over 2a, where ax squared plus bx plus c equals 0. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant. It has a plus and minus in the middle, which will split out into two different answers, which gives us our two roots of the quadratic. There are some cases where you won't be able to use factorization. So in most cases, you can use both. But if you cannot use factorization, they will hint at you. They will tell you in their way that you can't use factorization. You must use the quadratic formula. So some ways to think of this would be give your answer correct to decimal places. As soon as you see that, you need to go ding, ding, ding. They're telling me to use the quadratic formula. Give your answer in third form. Ding, ding, ding. Quadratic formula. They could give you something that looks like third form. Ding, ding, ding. Quadratic formula. So always watch out for that. So now let's look at an example. Solve the following equation to 2 decimal places. So this thing here, 2 decimal places, is hinting at us. They are saying we need to use the quadratic formula. Okay, so watch out for things like this in exam questions. So the first thing I'm going to do, if I'm going to use this, and I would strongly recommend that you're using your own log tables, because remember, you're going to have log tables in your exam. So there's no point working off a formula that I'm writing down. Look at page 20. I'm at the very top, the roots of a quadratic equation. They give us a formula there for the quadratic, and that is ax squared plus bx plus c equals 0. I love writing this underneath because then it's really clear for me to see what is a, what is b, and what is c. So a is 2, b is 9, and c is minus 16. So I'm looking at the coefficient of x squared, I'm looking at the coefficient of x, and I'm looking at the constant. The formula then is x equals minus b plus or minus square root b squared minus 4ac all over 2a. So we write out our formula. We then substitute in what we have. Remember, substitution should always be with a bracket. Don't get lazy with this because as the numbers turn negative, the bracket can have a huge impact, especially with squaring negative numbers. Minus 4, a is 2, and c is minus 16. This is all over, so be careful with that. The whole thing is over 2 times 2, so 2a. We're going to do a little bit of cleanup here. So minus 9 is minus 9, plus or minus square root 9 squared is 81. 4 by 2 is 8. By 16 is 128. We have a minus by minus, so this is plus 128 all over 4. We'll do a little bit of tidy up. 81 plus 128 gives me 209. So I have x equals minus 9 plus or minus square root of 209 all over 4. So we're going to split this out into two answers. The first one I'm going to do is where we have the plus. So this is x equals minus 9 plus root 209 over 4. And remember, we want this correct to 2 decimal places. So if you're putting that into the calculator, press your fraction button first, then minus 9 plus the square root of 209. Use your arrow button to go down all over 4. It will return this to you as a third. So we want to then convert it to a decimal, and we get 1.36. We then work out the minus. So where we put the minus in the formula, so x equals minus 9 minus square root 209 all over 4. If you want to be a bit clever, go back to your calculator. Don't clear anything. I have the last sum on my screen. I use my back arrow to get into the fraction, and I change that plus to a minus. So it saves me typing. Don't worry about the third answer. Instead, we want to get the x in terms of, x in decimals. So you're using your S to D button, minus 5.86. And there are two answers. So let's try another one. And this one asks us to leave it in third form. Again, this is a big hint to us that we're using the minus b formula. So first thing we do, I'm looking at page 20, top of page 20. I have ax squared plus bx plus c equals 0. A is 3, b is 12, c is 1. The formula is x equals minus b plus or minus square root b squared minus 4ac. all over 2a. X equals minus, remember to use your brackets. It's a really good habit to get into, even if you're going, it won't make a difference in this question. But if you always do it, then it won't matter. You won't need to worry about when to do it, when not to do it. You just do it out of habit. All over 2 times 1. Let's clean this up. So we have minus 12 plus or minus square root 144 minus 12 all over 2. Let's tidy this up again. X equals minus 12 plus or minus square root 132 all over 2. So again, I'm going to my calculator and I'm going to do the plus one first. Again, you want to press your fraction button first. Minus 12 plus square root of 132 all over 2. And that gives us a nice answer, well, nicer answer of minus 6 plus root 33. So the calculator will actually simplify your third for you. And if you'd want a decimal, we could have just then pressed the S to D if you're using Casio, or the change button if you are using Sharp. Again, for the minus, I'm going to be clever and go backwards, back arrow into my sum, change that plus to a minus to save me typing it again. And that is minus 6 minus root 33. And actually, you might notice something interesting here with our answers. And the answers have just changed that sign. So the plus before the square root has changed to a minus. And that will always be the case. If you have already revised or already covered thirds, you might be aware of what this is. And this is called the conjugate, where we change the sign. And those two roots should always be the same, with the sign in front of the square root, one a plus and one a minus. So now let's look at an equation with fractions. So there's a funny looking sum, but they've given us a nice little hint. So we have x minus 6 equals 3 over x. I strongly recommend that you get into the habit of writing fractions with the denominator lower. And what I mean by that is the numerator should be on the same line as any whole numbers, because remember, any whole numbers can be written over 1. So we're leaving the space for their denominator. So the little note they gave with this is it's not always obvious that we are dealing with an equation in the form ax squared plus bx plus c equals 0. So the first thing we're going to do, we're going to get rid of that fraction, because who wants to deal with a fraction? I don't, and I don't have to, because I have an equation. And I can do whatever I want to the equation as long as I do it to both sides. So we have a rule to get rid of fractions, and that rule is we multiply across by the denominator. I like to multiply each term individually by the denominator, and that helps when we've multiple fractions. Doesn't make a huge difference in this question, but it's a habit I got into. So here, the x on the top divides with the x on the bottom, or cancels if you like, leaving us with just 3. So we get x by x, which is x squared, minus 6 by x, which is minus 6x, equals 3. So we're not quite looking like this yet, not quite. So I actually need to take away a 3 from both sides, and when I do that, I get x squared. Now, I can't take a 3 away from a 6x. Not possible. So I get minus 6x minus 3 equals 0. And now it looks like ax squared plus bx plus c equals 0. So there was a little bit of work that was needed first. So here's my ax squared plus bx plus c equals 0. Now, what this question wasn't good at doing was telling us that we were going to have to use the quadratic formula. We're going to do that, and we're going to leave it in third form. So we have a equals, now there's no coefficient here with x squared, but if I have an x squared, I have 1x squared. So no coefficient really is a coefficient of 1. B is minus 6 and c is minus 3. The formula is x equals minus b plus or minus square root b squared minus 4ac all over 2a. So x equals minus 6. Remember to use your brackets, watch your signs. Minus 6 squared minus 4 times 1 times minus 3 all over 2 times 1. Cleaning this up, we have a minus 6, which actually is just a 6, plus or minus square root of minus 6 squared is 36. So just be careful. Use your brackets. If you don't use your brackets, something can go wrong, especially on the calculator. Minus 4 by 1 by minus 3 is plus 12 all over 2. And this gives us 6. Oh, plus or minus, kind of running out of space. Square root of 48 over 2. I'm going to do my two answers here if I have space. So into your calculator, remember fraction button for 6 plus square root of 48 over 2. And that gives us 3 plus, oh, I should write my x equals, 1 second. So my answer is x equals 3 plus 2 root 3. Go back and change that plus to a minus. Or if you remember what we talked about in the last example, it is going to be the conjugate. So you simply change the sign in front of the square root. So finding the roots of the equation is just another way to ask you to solve the equation. So we have a graph here on the right and it cuts the x-axis at the points minus 2 and 3. And these are the roots. And these are what we would get if we solved the equation. Just be aware, if they wanted the points or if they wanted the x-intercepts, we would write them as points, which is not just x equals minus 2 and x equals 3, but instead writing it as minus 2, 0 and 3, 0. Let's look at an example where we're asked to find these roots of a quadratic function. So here we have just a function notation. If you haven't yet done functions, don't worry about it. But this is another way we could be asked to solve it. And effectively what we're doing is looking for the roots. So we've been given f of x, a function f, and they've told us to solve f of x equal to 0. So instead of f of x, we have 2x squared plus x minus 6 equals 0. And now all we have is a quadratic equation. So we're going to solve this using factorization because they didn't mention anything at all about needing to give it in decimal or third form. My guide number is 2 by minus 6, which is minus 12. I want the factors that will give me the coefficient of my x, which is a plus 1. So we're going to use 3 and 4. Minus 3 and plus 4 will give us what we want. We have 2x squared. We're going to split that 1x into minus 3x plus 4x minus 6 equals 0. The first group here and the second group here, the first group has an x in common, leaving us with 2x minus 3. The second group has a 2 in common, again leaving us with a 2x minus 3. We're double checking that our brackets are the same. They are. That gives us 2x minus 3 times x plus 2 equals 0. We're going to use the zero product property to say that, well, either 2x minus 3 equals 0 or x plus 2 equals 0. We're going to use vertical balancing then to finish this off. So I'm going to add a 3 to both sides. So I get 2x equals 3, divide both sides by 2. So x equals 3 over 2, or if you prefer, 1.5. Or maybe x plus 2 equals 0. Again, vertical balancing, taking away a 2 from both sides, that gives us x equals minus 2. Now, if we were to sketch this, what we've done is we have a positive quadratic, and I know it's positive because 2x squared, that is the leading coefficient. So 2 is the leading coefficient and it's positive, so it's positive quadratic. And the roots are x equals minus 2 and x equals 1.5. There's one other important piece that we could mark on our graph, and that is the constant. So the minus 6 always represents our y-intercept, so where it crosses the y-axis. So that there is minus 6.